Well, welcome. I am Mr. Murphy, and in this particular video we're going to be looking at our Power Standard skill number 3. And in skill number 3 we're looking at story problems and how to figure out what the domain of that particular story problem would be. Now, I know story problems aren't everybody's favorite, but I'm hoping that by watching this video and learning some little tricks and things to look for, it'll help you learn how to find that domain. Let's look at an example of a couple of story problems that you'll be doing in a minute, and then we'll look at some terminology that's important for you to understand before we can find out what the domain of these story problems will be. So let's look at some examples. So here we have an example dealing with the volume of a sphere. They give us that formula, V equals 4/3 times pi r cubed is the volume of a sphere. And we want to figure out what the domain of that particular function would be. Or down here we have this example where it talks about John going on an 8-hour bike ride and trying to figure out what the domain of that particular function would be. So these are ones that you'll be attempting on your own here in a minute. But first, let's make sure we understand some basic terminology. Let's start with, well, what even is a function? If you haven't seen the previous videos where we defined those, you might want to go back. Otherwise, here we have the function defined for us. The definition of a function is that it's an equation where each input value results in a unique output value. So for every number that we put into the equation, we're only going to get one output value. If that happens, we're working with a function. Now, what is the domain? Because that's what we're being asked for here. What is the domain for these story problems? What is the domain for the function? Well, the domain is the set of all possible input values, which are usually going to be x's, or if we're dealing with a story problem, we might be working with a different variable, but it's looking at the input value, or the independent variable is going to be where we get our domain from. And it's all the ones that would produce a valid value for that particular function. So that input value, that's what we call our independent variable. And like I said, usually it's an x, but since we're dealing with story problems, we're not always going to be working with x's. And the dependent value is going to be referring to your output. So let's look more at, if we're looking at a story problem, how do we know what our input, how do we know what our independent variable is going to be? Well, the independent variable is, like I said, it is the input variable. It's going to be the variable in the story problem that occurs on its own. It doesn't depend on anything. It's completely independent. Makes sense then to call it the independent variable. So the value of the dependent variable depends on the value of the input variable. And so it's important to, when we're looking at a story problem, to first identify what is my independent variable and what is my dependent variable. Because making that clear will help us figure out where we're going to get our domain from. Because our domain, remember, we get from the independent variable. So here's an example. Here we have a pie eating contest that it took Ben 16 minutes to finish 4 pies. We want to figure out what's the domain for Ben's competition here. Well, in order to figure out what the domain is going to be, I got to figure out, well, between the two values I have, it took him 16 minutes to eat those 4 pies. Well, out of those two, one of them is going to be my independent variable and one of them is going to be my dependent variable. Well, to give you a hint, anytime we're working with time, it's almost always going to be, the time is going to be your independent variable because time occurs on its own. The number of pies that he eats depends on how long he's been eating. And so the independent variable, like I said, would be your time. The number of pies he's eaten is going to be your dependent variable. So how do we write that domain then? Well, let's look more at that. If you've looked at the previous videos, we've been working with set builder notation. We're going to be doing the same thing here. We're going to write our answers using set builder notation. So let's look at how we would do that one, and then we have another story problem that we're going to look at together dealing with the area of a circle. So let's look at how to identify the domain for these two, and then I'll let you loose and have you try a couple of those previous problems that we saw already. I'll have you try those on your own. So the way that we would write this out now, using that set builder notation, well, first remember that we're looking at your time here, so you can use whatever variable you want. You can use m for minutes, you can use t for time to represent your independent variable. But we would say then that our domain is going to be the set of, I'll use m for minutes, such that, now he ended after 16 minutes. So he started at 0 minutes, started eating his pies, and he ended at 16 minutes. So our time, our number of minutes, goes from 0 to 16. So that's how we would write this using set builder notation. Because again, this represents the fact that the number of minutes, the smallest amount was 0, and after 16 minutes he was finished, and so it ends at 16. Now there are going to be times where it keeps going on infinitely, where it doesn't have a limit like this one, like for example the area of a circle. Now you want to recall that the area of a circle is found by taking pi times the radius squared. And for this situation, we're looking at our independent variable would be our r. So r would be your independent variable. So that's what we're going to be looking at for our domain. Well, if you think about it, you're not going to have a radius that's going to be a negative value. Technically, we could use 0 for r. So the way that we're going to write this is we're going to say that your domain for your r's is going to be the set of is going to be set going from where our radius is going to be greater than or equal to 0. So this would be how we'd write our domain in this situation, because you could have a radius of 1,000,000 inches or whatever the units would be. So it keeps going on infinitely. You could have any value greater than or equal to 0 for your radius. You would just never have a negative value for your radius. And if you had a radius of 0, you're not dealing with a circle. It's just have an area of 0, I should say. Okay, so I want you now to try these two. Here we have the volume of a sphere with the radius r given by the formula v equals 4/3 pi r cubed. So I want you to figure out what the domain for that function would be. And then look at the story problem. I want you to find the domain for that situation as well. So why don't you go ahead, pause the video, and hit play when you're ready to check your answer. Okay, so let's see how you did with this. So with this particular situation with the volume, you want to think about it, well, your independent variable is your radius, and you want to think, well, I can't have a negative value for the radius, and it could be any large number, so it would go infinitely as far as x is concerned in the positive direction. So the domain here we could define as being the set of all r's such that r is greater than or equal to 0. It's exactly the same as the area of a circle was. Now the next one with this story problem might have been a little tricky. It says John went on an 8-hour bike ride and traveled at a rate of 20 miles per hour. His distance is calculated by the formula d equals 20 times t. State the domain of the function. So in this scenario, your t, your time, is your independent variable, and it's not going to be infinite, and he's not going to have a negative value for time. The time for his bike ride ended after 8 hours, or ended at 8 hours. So our domain here for this scenario would be the set of all t's such that now he would have started at 0 minutes or 0 hours. Is less than or equal to t, which is less than or equal to when he ended 8 hours later. So that would be your domain. Well, there you have it. This is Power Standard Skill number 3. So hopefully after watching this video now you have a better understanding of how to figure out what the domain for a function is when we're looking at a story problem or when we're looking at a formula. And with that, good luck now as you try some of these on your own.